Okay, so let's go through the naming. I'm going to use the periodic table kind of as my guide. And we're going to start. And my Monday group has already been through this, but you'll get to hear it again. If you don't think that you need to hear it, you just keep working on your pay total attention to me. But those people that didn't, my Friday group, you definitely want to pay attention. So the first thing I name are binary compounds. What's it mean to be binary? How would you recognize a compound that is binary? Two what? 2 elements. It only has 2 elements. Start by naming those, which means that there's no polyatomics in it. Your polyatomics are going to be the next thing that we name, but we're going to start with binary. So you have 2 elements, and we're going to start with group 1 and group 2 elements first. So, what is so special about group 1 and group 2 metals in terms of their charge? Okay, everything that's a metal is going to have a positive charge. It's always going to be listed first. But what is special about group 1 and group 2 metals with the charges? Okay, we always know their charges. So group 1 is always positive 1, group 2 is always positive 2. So the nice thing about anything that is in a group that has a group 1 and group 2, you just name it. You don't need to put special prefixes. You don't need to use your stock system, you just name it. So, let's name this. First of all, we recognize that it's binary. We have 2 elements. We have magnesium and chlorine. We look on the periodic table. We find where magnesium is. Oh, it's in a group 2. So we just name it. Now, when you name it, you name the metal. Then it will be with a non-metal. And you're going to put an IDE ending in it. So you're going to name the metal. You're going to name the non-metal with an IDE ending. So how would you name this? What's Mg? Magnesium. Then you have chlorine, but instead of chlorine, you're going to put an IDE ending. Chloride. You would put chloride, exactly. This IDE ending tells you that it's binary. So if you get the name and you need to write the formula, the IDE, except for 2 polyatomics, the IDE ending will tell you that it's binary. Let's name, let's provide a formula for that, for calcium sulfide. First of all, it has an IDE ending, so you know it's binary. Then you look at calcium, and what group is it in? Group 2. So it's just going to have the name. Calcium is what? Ca, what's the charge on it? +2. Sulfide, what non-metal is that? Sulfur. What charge is sulfur? As an anion, because it's listed second. -2. How do these 2 come together? Do the crossover rule. But you want to reduce them because it is ionic, so they come together in a fixed ratio. 1-to-1, lowest whole number ratio is the word I wanted. So 1-to-1, 1-to-3, whatever, but it comes in a whole number ratio. So in this case, it's going to be 1-to-1. So they come together as calcium, 1 calcium to 1 sulfur. Now we're going to move over in the periodic table, and we're going to do transition metals. One thing I want to add, group 3, your boron, aluminum, gallium, will always be a +3. Okay, boron, aluminum, gallium will always be a +3. So before, let's do transition metals. What is the charge on your transition metals? We don't know. They vary. If you guys remember from when we did iron could be +1, +2, +3. Chromium could be +3, +6. Copper's +1 and +2. So they can vary. So instead of us memorizing what each of them are, we're going to use the stock system. So I'm making a new transition, metal, non-metal combination. So with the transition metal, we're going to use the stock system. Which is basically the charge in parentheses behind the name. So you're going to name the metal. And we're going to use the stock system, Roman numerals, that represent the charge on the metal. And then non-metal with an IDE ending. Again, the IDE ending tells you that it's binary. So let's do an example. This is why in lesson 1, I had you learn how to determine the charges, the oxidation numbers on each of the atoms. I did that first so that when we did the transition metals, you would understand how to get those charges. You see the method to my madness. Okay, so you don't know what copper is. You know it's copper bromide, but you know that copper is a transition metal, so you've got to use the stock system because you don't know what the charge is. But you do know what bromine is, so you're always going to know what the anion portion is, what that charge is, in order to figure out what the metal charge is. Does that make sense? So you're going to kind of, well, exactly what we did in lesson 1. So bromine is listed second, so it's going to be a negative charge. And what charge will bromine be as an anion? -1. Remember, the whole thing has to be equal to 0 because copper bromide, CuBr2, doesn't show a charge. So -1 times 2 is what? -2. We don't know what each copper is, but if we do a little math, not high order math here, what -2 is 0? +2. So each copper has a +2 charge. So the name of this is copper, Roman numeral 2. That Roman numeral 2 represents the charge on copper, the bromide. Again, the IDE ending tells you that it's binary. Good? Questions with that? Britton, you good? What about named formula? Iron 3 oxide. So now we have the name, and we want to put it into its formula. So on this test, you'll be given the name, and you have to provide the formula, and you'll get the formula, and you got to give me the name. So you'll have both. Iron 3 oxide, where do we start? Well, we know we have an Fe and we know we have an O. So we're going to start by writing that. What is the charge on iron? +3, how do you know that? Roman numeral 3. What's the charge on oxygen? -2, how do we know that? Because it's in group 6 and it's 2 away from being like a noble gas, so it will tend to gain 2 electrons. And plus oxygen. So how do you determine the formula? Crossover rule. So it's Fe2O3. That's just my work above there. There you go. Iron 3 oxide. Very good. Okay, the last variation. So notice how I went from group 1, group 2, non-metal, transition metal, non-metal, and now we're going to have our last binary combination, and that is non-metal, non-metal. Now this is a little bit different in that we're going to use prefixes because what kind of compounds are these when you have a non-metal with a non-metal? How are they bonded? Covalently bonded. So our other 2 examples were all ionically bonded, so they had a set charge, so you can kind of figure out what the ratios were. Here, it's non-metal, non-metal, so the charges are not a full negative and a full positive, but we can determine what the subscripts are based on the prefixes in front. So the prefixes will tell you the number of atoms, or the number of elements. So you're going to use a prefix, and I'll tell you what the prefixes are. And you're going to name the non-metal, and then prefix, non-metal, again, IDE ending. The IDE ending tells you that you have a binary. The prefixes in front will tell you that it's a non-metal, non-metal covalent combination. So let's do S2O4. So the prefixes are going to be Latin prefix. If you have 1, it is mono. I don't know if you guys can see this or not. 2 is di. 3 is tri. 4 is tetra. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. There you go. I took Latin in college for 4 semesters, and this is how it helped. Right? So, again, the prefixes in front describe how many atoms you have. So we have 2 atoms of sulfur. So what is that? Disulfur. We have 4 oxygens. So it's going to be tetra. And we're going to just say tetroxide because it's easier to say than tetraoxide. So tetroxide. So when vowels are next to each other, you want to drop one of them. Sulfur, tetroxide, tetroxide. Yes, that's right. What about that? Sulfur dioxide. When there is 1 sulfur or 1 atom, initially you don't need to write mono because it's understood to be 1. So this would be sulfur dioxide. A good example is CO2. How do you say CO2? How do you name it? Carbon dioxide, you don't say monocarbon dioxide, right? You say carbon dioxide. I didn't even hear you. So this is how you name binary. Everybody good? So the IDE ending will tell you that it's binary. Except two polyatomics, and we're going to do polyatomics next. Everybody have this? Anybody want to take a picture? Good pictures? Going once. Going twice. Brittany, you getting it? It's going to be gone soon, so you better get it. Got it? Okay. Okay, so the next set of compounds to name have polyatomics in them. And you guys have memorized your polyatomics because that's how you spend your weekend, I'm sure, going through your polyatomic ions. So the first of all, there's two polyatomics that have IDE endings. What are they? Hydroxide and cyanide. So that's it. And you can forget about that, but if you go to try to find an element of hydroxygen or whatever it is, you can't find it. So hopefully you'll say, oh, that's probably not binary. It's probably one of those polyatomics that I had to remember. Or cyanide, same thing, cyanogen, whatever. However you want to try to find it. But anyways, those are the other two polyatomics that end in 90. So we're going to start by doing a group 1 and group 2 and a polyatomic combination. And you just name it. The reason why you can just name these is you know the charge on your group 1 and group 2, and you know the charge on your polyatomic. You don't have to put prefixes, you don't need to put Roman numerals because you know the charges on them. How would you name this? Well, the first thing you need to recognize is that it's not a binary, right? There's 3 different types of atoms. And then what do? You look to see the metal. Is it a group 1 or group 2, or is it a transition metal? It's 2, so you just name it. Anybody want to give it a try? Magnesium. And then you have memorized what that guy is. What is it? Sulfate. Magnesium sulfate. You can just say it. Notice how all of your ions, all of your polyatomics end in ates or ites. Anybody know what magnesium sulfate is? Epsom salts. Salts, just as a FYI, salts are things with group 1 and group 2 metals in them because they completely ionize in water. Well, most of them. You'll see later, calcium sometimes. They're called salts because they ionize, so in water, you'll have magnesium ions floating around, you'll have sulfate ions floating around. They completely ionize, they're not hooked together anymore. They are ions in solution. What about sodium, hydrogen, carbonate, or bicarbonate? Sodium, hydrogen, and carbonate. Hydrogen carbonate or bicarbonate are the same ions. The bicarbonate is an older way of naming it, but you've probably heard of that in biology. Heard of bicarbonate? So how do we want to put the formula together? Sodium is Na. What's the charge? What about hydrogen carbonate? HCO3, and that has a -1. How do these two come together? Just like that. NaHCO3. What is this guy? Sodium hydrogen carbonate. Right now? Baking soda. What does sodium carbonate look like? Sodium carbonate. Well, we have an Na with a plus charge. What does the carbonate ion look like? CO3. Now watch. If this has a -1, hydrogens usually have a +1, so it added a +1 to that. So what do you think carbonate is? -2. So how do you Na2. So you need 2 sodium ions for every one of them. We go with that. Moving on, we'll do transition metals. So we have a transition metal polyatomic. Again, you've got to use the stock system with this because the transition metals vary. So let's do so we've got to determine the charge on the iron. What does this parentheses mean? There's 2 ClO4, so that's your polyatomic, and you need 2 of them. The ClO4 doesn't ionize in solution. ClO4, a Cl and an O are both nonmetal. So what do you know about the bonding within the polyatomic? It's covalently bonded, so they don't break up into Cl and 4 oxygens. They stay together as a unit. So you're going to balance them as a unit. So in solution, the ClO4 stays all together as a chunk. And that's why you got to use parentheses around it. So ClO4 is what? Perchlorate. What charge does that have? -1. And you needed 2 of them. -2, the whole thing is 0. So what does each, it's not a plus sign. Okay. What does each iron have to be? What? -2 is 0. There I go again with the high order math. +2, so each iron has a +2 charge. So how would you name this? Iron 2, that has to do with the charge. Perchlorate. Good. Let's do. Let's try that one. How are you going to name this? Well, we know we have a copper. We got to figure out the charge on that copper. What is this thing? SO3. It's not sulfate. It's sulfite. Notice with all of your polyatomics, and there's no, oh, the 4 oxygen's always an 8 and the 3 oxygen's always an 8. Unfortunately, it's not because you have nitrate in there that is 3 oxygens in 2. But the higher number of oxygens on there always have the 8, and the lower numbers always have the ite. Okay? So this is sulfite, but the charges are all the same. nice thing. So if you know sulfate is SO4, then you know sulfite is SO3, and they each have a -2. So what does each copper have to be? What? Times 2 minus 2 is 0. What does each copper have to be? 3 plus 1. Right?
I was just like crossing them. I didn't realize it was 2 numbers. If it was just C use 1, so 3, then it would be 3.
This.
Never.
Are you getting confused with this 3? Okay.
This
No. But people have done that. That's why I'm asking you what you did, so I can. So this SO3 is a whole chunk.
Yeah.
Okay. So that the SO3 is one big unit. And each one of them is a -2. And you have 2 coppers, 2 times X, or 2X. So what? That has to be plus 1 to get that at 2. Minus 2 is 0. So each copper is a plus 1. Are we okay with that? Yeah? Okay. Copper 1 sulfite. Let's do one more. What about that one? CR. CR is what? Chromium. What is NO3? Nitrate. What charge does it have? -1. -1 times 3 is? -3. So what does chromium have to be? Plus 3. So this is chromium 3 nitrate. Okay, last combination is polyatomic. And there's really only one cation that's a polyatomic, or polyatomic that's a cation. Which one is that? Ammonium. And honestly, with polyatomic, you know the charge, just name it. So the only time that you have to use the prefixes, stock system with transition metals, and besides that, you just name it. The only reason you have to use the transition metal, you have to use the stock system, is because the transition metal charge will vary. And the only reason you have to do prefixes with non-metals is because they also will vary depending on what it's with. Go ahead.
Do the charges vary because of the stock level?
Yes, because you can, and if you remember when we did iron plus 1, iron plus 2, iron plus 3, they can lose all those electrons. They can lose 1 and be happy because you'll have a 4s2 3d5. They can lose 2 and be happy because it'll be a 4s1, I'm doing iron here, 4s1 3d5. And then it can lose 3 because it can be a 4s0 3d5. So you can have all those combinations where you have a half-filled, either a half-filled subshell or a empty one. copper will end up being a +1 or +2. I don't see it +3. I don't. But anyway, instead of having to memorize all those, the stock system will tell you. Everybody good with that? Okay. I'm going to turn this off. I'm going to do another one.